I bet you didn't know that the Bullseye Galaxy, also known as NGC 4725, showcases a rare cosmic collision. Its 9 rings are a testament to the dramatic events that have shaped it. At the core of this galaxy lies a bright active nucleus. Surrounding it, regions of intense star formation create new stars. The spiral arms of the Bullseye Galaxy extend outward, showcasing its intricate structure. Cosmic dust and gas within the galaxy contribute to its unique appearance. Simulations of galaxy collisions help us understand these complex interactions. Over billions of years, such events shaped the evolution of galaxies. Observations from telescopes like Hubble provide us with detailed images of these phenomena. Galaxies are not isolated, they exist within clusters and the larger cosmic web. Dark matter plays a crucial role in the formation and interaction of galaxies. In the distant future, our Milky Way is expected to collide with the Andromeda Galaxy. These cosmic events remind us of the dynamic and ever-changing nature of the universe. Recently, the Bullseye Galaxy, officially known as LEDA 1313424, has revealed a stunning cosmic event. NASA's Hubble Space Telescope captured this rare phenomenon, showing the Bullseye Galaxy marked by 9 distinct rings. This discovery changes how astronomers view galaxy interactions, providing a rare glimpse into the rippling effects of a high-speed collision. A much smaller blue dwarf galaxy pierced straight through the Bullseye's heart, leaving behind an intricate pattern of expanding rings. These rings, filled with newborn stars, resemble ripples in a pond. While previous studies of ring galaxies identified only 2 or 3 rings at most, this system has shattered that record. The process behind this extraordinary formation mirrors events found in nature. Consider the northern gannet, a seabird known for its high-speed dives into the ocean from as high as 100 feet. It plummets into the water in pursuit of fish. Its pointed beak and tightly folded wings reduce splash, but the impact still sends tiny ripples outward. Now scale that scenario to galactic proportions. Instead of a bird, imagine a tiny galaxy plunging into a much larger one. Instead of water, envision a vast galactic disk filled with stars, gas, and dust. 50 million years ago, when the blue dwarf galaxy passed through the core of the Bullseye, the cosmic ripples left in its wake pushed material both inward and outward, shaping the structure of the larger galaxy. Seeing such a phenomenon in detail is rare. Both the Hubble Space Telescope and the W.M. Keck Observatory in Hawaii confirmed the existence of 9 rings in the Bullseye Galaxy. This is more than double the number seen in any other known ring galaxy. Hubble also identified the intruding galaxy, which now sits to the left of the Bullseye. This was a serendipitous discovery, said Imad Pasha, the lead researcher and a doctoral student at Yale University. I was looking at a ground-based imaging survey, and when I saw a galaxy with several clear rings, I was immediately drawn to it. I had to stop to investigate it. The name Bullseye perfectly describes the galaxy's appearance, with each ring resembling a mark left by a cosmic arrow. The rings are not merely decorative features, they represent powerful waves of star formation triggered by the dwarf galaxy's high-speed passage. For perspective, the Milky Way spans about 100,000 light-years across. The Bullseye Galaxy, at 250,000 light-years in diameter, is more than twice as large. Its massive size makes the rings even more striking as they continue expanding outward. Hubble's crisp imaging allowed researchers to pinpoint most of the rings, many of which are clustered near the center. This would have been impossible without Hubble, Pasha explained. The telescope's high resolution provided an unparalleled look at the Bullseye's structure, revealing intricate details invisible to ground-based observatories. The Keck Observatory in Hawaii played a crucial role in confirming 1 additional ring, bringing the total to 9. Researchers believe a 10th ring may have once existed but has since faded beyond detectability. If this lost ring still remains in some form, it would be located 3 times farther than the outermost ring captured by Hubble. The Bullseye Galaxy aligns almost perfectly with long-standing theories about ring formation. Models predict that a galaxy hit in this way should produce a series of outward-moving rings. And this is exactly what astronomers observed. That theory was developed for the day that someone saw so many rings, Van Dockum said. It is immensely gratifying to confirm this long-standing prediction with the Bullseye Galaxy. Hubble's image provides an angled view of the rings, making them appear unevenly spaced. If seen directly from above, they would form nearly perfect circles, with the innermost rings packed closely together and the outermost ones more widely spaced. To understand how these rings formed, imagine a pebble dropped into a pond. The first ripple spreads out widest, while others follow at regular intervals. In the Bullseye Galaxy, the first two rings likely formed rapidly and expanded outward. Later rings appeared in sequence, slightly offset by the continued movement of gas and dust. The passage of the blue dwarf galaxy affected the earliest rings the most, triggering a chain reaction that lasted millions of years. While individual stars remained largely undisturbed, entire groups of stars piled up to form the visible rings. Meanwhile, gas was carried outward and mixed with dust, fueling the creation of new stars. Despite the clarity of this discovery, many questions remain. Astronomers want to determine which stars existed before the dwarf galaxy's arrival and which formed afterward. This will help refine models of galaxy evolution and provide insight into the long-term fate of the bullseye. Over time, some of the rings will fade as stars move out of alignment. However, the larger structure of the bullseye will persist for millions of years, giving astronomers plenty of time to study its evolution.